So let's look at this question here, which is on binomial distribution, I believe. So given that this question was taken from 2017 VJC, J2 mid-year, paper 1, question 11. So a trial for a new treatment for a particular disease is to be carried out. Sample of N patients suffering from this disease is taken, and these patients are invited to take part in the trial. So the number of patients in the sample who accepts the invitation is denoted by X. Okay, so in context of in context, the assumption needed for X to be well modeled by the binomial distribution. So this case here, the assumption needed is essentially something which is not already stated. Okay, the assumption would be because you have already given they already told you that is either they accept or they don't accept, right? So assumption needed is that assumptions needed. Number one, that the first thing is basically you have to assume that suffering from disease taken patients in trial. So assume that each patient's decision to take part in the trial is independent of another patient's decision. Okay, that is very important. It has to be independent of each other, right? Then what else do you have? A sample of N trials so taken part. So who accept the invitation? So two assumptions needed. Another assumption would be, very importantly, each patient's probability of success must be constant, right? So each patient has the same probability of accepting the invitation to take part in the trial. Okay, so these are the two very important assumptions, because it's not stated in the question. You need to state what is not given in the question. So the assumption is actually each patient's decision to take the part in the trial is independent of another patient's decision, and also each patient has the same probability of accepting the invitation to take part in the trial. Okay, so that is how we do this first part here. Let's look at the subsequent part. So for subsequent part, assuming the X has distribution of B10 0.25, this case here, part 2, find a probable number of patients who accept the invitation. So this case here, X, B, you have 10 patients, and each patient have 25% chance of accepting it. So 10, this is 0.25, right? So in other words, most probable number of patients who accept would be, just use your GC, and we're just going to label the PDF out, right? Just use, this is very important. What you're going to do is actually just clear it and just go to distribution binomial, PDF here, put it trial as 20, or 10, sorry, 10, and this is 0.25, put this as X, okay? So key in and go to table set of 1. Remember, we start counting from 0. So you can see that the most probable number would be the 2, right? So this case here, these are all the probability. Okay, the highest probability will be the most probable number. So let me just copy this down. Here, what we have is, this is R, and this is Px equals to R. Or you can just use X as well. It's fine. So the most probable number is this one here. So from GC, most probable number is 2. Okay, so that's how you do this part here. I think it's fairly quick, this part here. Let's look at part 3. Find a probability that exactly 6 patients accept the invitation, given that at least 1 patient accept the invitation. Okay, so for part 3, it's a conditional probability. The required probability here will be Find the probability that exactly 6 patients accept the invitation. So X equals to 6, right? Given that at least one patient accepted the invitation, so at least one as such, right? So this case here will just be Px equals to 6 intersect with X bigger equals to 1, and out which Px at least 1. Okay, just think about it as if you already given the condition where or at least one will accept, right? What's the chances that that 6 of them will accept? So one patient accepts, at least one patient accepts invitation. So this case here is pretty okay. I think when you intersect X equals to 6, X bigger than 1, at least 1. The top would just be Px equals to 6. Okay, this is at least 1, so it's Px equals to 0. I think it's pretty okay. Then this case here, what we get is actually just key in calculator. This part will be just key in Px equals to 6, so it's PDF. This case here, PDF. These trials would be 2.5, and this would just be 6. Enter. Yeah. So annoying. Very hard to use VJC because it's so difficult. 1 minus X equals to 0, so we could just put distribution Px PDF as well, and just put this as 0. Okay, you could just put 0.75 to the power of 10 as well. It's okay, that's understanding. So this would be, I hope this is a, yeah, am I calling it correct? Okay, 0.01719. 0.01719. So this is 0.0172. Okay, so that's how I do this question here proficiently. Now, if you have any question or comments, please do let me know, and I will see you in the next question.